Hello, welcome back to the last lesson in the sequence on the Pythagorean theorem, the distance formula, and the midpoint formula. Now, these problems are a little different from the last lesson. These problems kind of cross over into geometry territory a little bit. There's a close relationship between algebra and geometry, of course, and so we're going to be applying a lot of these ideas from basically algebra. We're going to be applying them to geometric figures. So they're kind of challenge problems, but they're also very practical. So in the first problem, I'm going to give you the vertices of a triangle. If you've taken geometry, you probably remember the vertices are just the corners of the triangle. I'm going to give you the coordinates of the corners of the vertices of this triangle. And I want to ask you, is the triangle isosceles? Yes or no? Is it a right triangle? Yes or no? And the third thing is, if it is a right triangle, we want to find its area. So I'm going to give you the vertices. We want to figure out, is it isosceles? Is it a right triangle? And if it is a right triangle, let's find the area. And so we have to dig a little deep and kind of go back to some things that we've learned from geometry. So the vertices of the triangle are given as follows. These are just the corner points. They're just going to be points in the xy plane. So we say that point A has a coordinate of -2, 2. We say that point B is located at 2, 1. And we say that C is located at 1, -3. And there's basically three things we want to figure out. The first thing is this triangle isosceles? Question mark. Is this triangle right? And if right, if it's a right triangle, find area. So in order to do this, we have to figure out and apply some of the things we've learned from geometry, some things you probably have been exposed to before. An isosceles triangle, what does it mean? It means that the triangle has two equal sides. If I make a triangle with my hands like this, roughly the same distance from my finger to my elbow and this finger to this elbow, two sides are the same. The third side can be a different length, but if two sides are the same, we call it an isosceles triangle. So we have these points, and so obviously to figure out if the thing is isosceles, we need to calculate the length of the different sides. But we're not given the lengths of the sides, we're given the corner points, the vertices. So how do we find the lengths? Well, we've been using the distance formula. We can find the distance between any of these points using the distance formula. Now, it doesn't tell you to do this, but it's always a good idea to make a little sketch whenever you start embarking on a challenging problem like this, because if you don't, you're just going to end up getting confused. So I always recommend, even if the problem really doesn't tell you, it's a good idea in general to plot, to do a little sketch here. So point A is located at -2, so there's -2 for x and 2 for y. So that's a point right here. So this is A, and this is -2, 2. That's that corner point right there. Now B is located at 2, 1. So that's 2 for x and up 1 for y. So this will be B, 2, 1. And then C is 1, -3. 1, -1, -2, -3. So there's a point down here someplace. That's C, 1, -3. Now obviously any 3 points can define a triangle. So it's not going to be perfect. I'm going to draw the connecting line here, I'm going to draw the connecting line here, and I'm going to draw the connecting line down here, and of course it's not perfect. So what we want to do is figure out, is this triangle isosceles? So what we need to do is calculate the length of each side of that triangle, and then we need to compare and just see if any two of those sides are the same length, then it would be isosceles. If they're all three different lengths, then it's definitely not isosceles. So we have to go crank through that. So in order to figure out the length of this side here, we're going to call it side AB because it goes between points A and point B. So we're going to figure out this length and we're going to use the distance formula. So it's, x2 minus x1 squared plus y2 minus y1 squared, and you take the square root of the whole thing. We're going to do it all, but we've done the thing so many times, I'm not going to write the distance formula out every time. We're just going to go ahead and do it. We take the x points. Let's start from B and subtract off A. So it'll be 2 minus this -2, 2 minus the -2, that's the subtraction of the x points squared. And then we have the y, which is 1 minus this, let's see, 2 comma, this is 2 comma 2 here. That's a very poorly written 2 right there, sorry about that. So this is -2 comma, let's write it clearly, 2, like this. And so we have 1 minus 2, and we're subtracting the same direction. We have to square that, and we're going to put a square root around the whole entire thing. All right, so length AB is going to be equal to